In this talk, I'm going to describe how OpenNebula works in a hybrid cloud computing environment. I'm going to more or less describe the interaction with Amazon EC2 in detail and give some hints about the same integration with Microsoft Azure. Okay. So hybrid cloud computing. This is more or less the architecture you're going to find with OpenNebula hybrid cloud computing. This may seem too evident for all of you now, but when we started in 2008, hybrid cloud computing wasn't really that natural for people, and the idea of combining your on-premise resources with an external provider was rather new. So in OpenNebula, we just wanted to have a single management layer that unifies and abstracts all the resources you can access to. This is kind of making the utility computing promise that we've been listening from the beginning of IT a reality, because you just really plug your system to the internet, and you can start getting compute power from any source, either in-house or going out to other external providers. So, as I said, when we started doing this, it was rather new, and we have like a very unique uptake in hybrid cloud computing that sometimes is going or has been adopted by others. But we wanted to really build with OpenNebula transparent integration, seamless integration with the external resources. So this is basically based on two different pillars. On one hand, we have the management interface, and regarding management, we see the hybrid clouds like any other host in your cloud. So you can have a KVM hypervisor, you can have an EC2 region or an Azure location, or as we've just seen, you can have a vCenter cluster. All of those resources are seen as the same thing for the cloud admin. They are managed under the same interface, and the information is monitored, and you get all the information through the same interface with the same set of metrics. So there's an effort here of trying to make uniform the information from different sources. So sometimes there's a mismatch because they are really different guys here. Okay, and also you have all the same capacity management techniques that you apply. So scheduling policies, they are working either for KVM hypervisors or vCenter or Amazon EC2. Accounting, you can account the usage on external cloud, so you can really check if Amazon is billing you the right amount of resources, for example. You can impose quotas, so you can force people to use or to offload only an amount of VMs to the external provider. And you can really fine-tune the capacity allocation you want to do on the external clouds, on your local hypervisors, and so on. So the management layer is really uniform across those different technologies to spin up virtual machines. But also, on the other hand, we wanted to make the same things from the user point of view. So we wanted to users or advanced users to use VMs local in the same way that they are going to use VMs in Amazon. So we also keep the same template definitions, capacity definitions, the same semantics for the operations, and also we wanted to give them the same workflow. So if they have the wrong way to contextualize, to interact with the VMs. So if we wanted to move or to implement the same mechanics as they are using in KVM, for example, in Amazon EC2. Okay, so that's the idea. Now I wanted to show you how it works for those of you that are not familiar with these things. So I wanted to show you how it tastes. Requirements. So I'm going to concentrate on EC2. Obviously, you have to have your access requirements by hand to access your account in EC2. You can configure EC2 to give you or to share accounts across users, but the idea is that you have to write down your access key and your access secret to configure OpenNebula. Then you have to enable the Amazon EC2 drivers. That's quite straightforward. It's like in KVM, just uncomment a couple of lines, and that's it. And then you have to define which Amazon EC2 zones you want to use in your cloud. How it looks. Okay, if you, let me show you where this file is. Maybe bigger. We have an EC2 driver.conf file, and in that file you basically define which regions of Amazon EC2 you are going to use and how much capacity do you want to overload at max for those regions. So for example here, I defined the North Virginia region, which is the US East 1 in terms of Amazon EC2, and I only want to use 3 M1.small VMs in that zone. And for example, I also defined the US West in Oregon, which is US West 2, and I just want to overload one M1.small instance. As you imagine, that those capacity definitions are the Amazon standard instance types, and you have to map that to the CPU and memory that we use in OpenNebula, which is more fine-grained. You go down in this file, you have all the mapping here. So what does it really mean? And M1.small, it's here. It means one CPU and 1.7 megabytes gigabytes in OpenNebula, right? So when we do the quotas, the accounting, all those things, it gets translated to this, right? So once you have that, it's just a matter of going to your Sandstone interface and create a host. I have already done that. For the presentation, and it gets something like this. So for example, this is the maybe a little bigger. This host here, which is US East North Virginia, it represents the Amazon EC2 zone, right? Together with it, I have the other Amazon EC2 zone and 3 local KVM hosts. As you can see, all those things looks the same for me under the interface. And if you go to one of them, for example, this one, you get all the monitoring information. Here, you see the total capacity, the CPU. That's not the whole North Virginia capacity, obviously. This is the amount of capacity you define you want to use in that zone, right? So right now I'm using like 10% of the total memory I want to overload to Amazon EC2, to these zones, right? New in this version, we wanted to concentrate all the configuration variables in the zone. So for example, here you have the EC2 access and secret keys for the account you want to use to access this zone. This is getting encrypted in the database, so you don't see here it's encrypted. So, but the idea is that you don't have to go to a file to update that. It's all configured here, right? Okay. Also here you see priority. Sometimes, or most of the times, when you configure your cloud and you have this hybrid setup, you want to prioritize your local infrastructure, and then if you are overload or whatever, go to the cloud, to the public provider. So how do we manage this? We have this. The scheduler can be configured to run a priority policy, and in this case, I put a -1 in this zone, which means that this is going to be used before, for example, or at the same time that this cloud, which is -1, but after these KVM1, KVM2, and server are full, right? If you go to one of them, they don't have any priority, which is defaults to 0. So you have a way to prioritize your local infrastructure compared to the external provider one. Okay. So this is how your hybrid cloud will look like, kind of. Okay, let's move on. So how do you define your VMs? So the basic VM definition is just grab your AMI ID and define a template for it. So I already done that. If you go, I prepare a couple of them. So for example, this one, which is a simple one. In the template definition, you have a hybrid section. So you go there. And in this case, I'm going to use Amazon EC2. And here I have all the Amazon EC2 related attributes. For example, I put the AMI, I put the instance type, which is going to be T1 micro instance. I pick the key pair I'm going to use with this instance. You can, this is important, which OpenNebula host, which translates to Amazon EC2 zone, are you going to use with this template. Here, this is for North Virginia because, as you probably know, the same ID is tied to Amazon EC2 zone, so these two have to match. But you can specify pretty much everything that you have in the Amazon EC2 interface. You can specify VPCs, device mapping, you can user data. I'm going to go back to that in a minute. Okay, so the basic idea is that you define the Amazon EC2 instance using all of the attributes you can use through the Amazon EC2 interface. So once you've done that, it's basically another template in OpenNebula. So you can go right away, instantiate, put like a name here, and that's it. Those sections doesn't apply for hybrid templates. And then go to the VMs, and we just created a new instance that is going to be allocated in the cloud, right? Let's wait a little bit since it spin-ups. Also, as you can mix different zones for a template, or you can even combine a single template with your local definition. So for example, I prepare another one, which is a complex one, because here I can have a template with two different providers. So when the scheduler pickup one is going to use the definition to corresponding to that zone. For example, I have this template is going to be instantiated in North Virginia, is going to use this AMI with this instance type of key pair, but if it happens to be instantiated in Oregon, it's going to use another AMI, and it's going to use another VPC or whatever. So you have, under the same template, it can be instantiated in different forms. And also, even you can add a local definition. So you can have a virtual machine template that if it's going to be instantiated locally, it's going to use a disk. It's going to be instantiated in North Virginia, it's going to use a given AMI, or it's going to use Microsoft Azure is going to use another thing. So that can be defined in a single entity. Okay. Also, you can do basically the same things through the same interface you do with KVM. Some of the operations are not available, like compared with KVM, because Amazon EC2 doesn't provide them, but you can do mostly everything, right? So for example, if you go to the VMs, there is no difference from the operational point of view. You pick this one, which is running. You get the monitoring information from the instance. Here, for example, all this information here is obtained through the monitorization process of OpenNebula. So you get the DNS name, the IPs, everything. You can interact with the VM. Like for example, I want to terminate this VM, and you can do so. And you can even include in the templates, like here, all the workflow that you are using with KVM. For example, if you are using context, that's going to be pushed to the Amazon EC2 instance. Or you can even interact with existing EC2 instances in Amazon. So let's take a look to this one. For example, here in this template, I prepare some context data. So when you instantiate the virtual machine, it sorry, not it once. I think I have one which is already deployed. No, sorry. Okay. So, for example, if you are going to deploy a MySQL database in Amazon EC2, you can put here your password, for example, or you can even put on a start script that, like you see yesterday here, to be executed on the Amazon EC2 instance. So I already have one of those deployed just to show you how it works. I have this one here. So I can just a minute to get the DNS name, which is this one. So when you go to the instance, sorry, you have to use the proper name. I picked the wrong one. Just a second. Okay. I think it's in my history, right? No. Yeah. It should be here. No? Let's try with, yeah. It's probably not. Yeah. Cool. Yeah, okay. So maybe here I have these. When you get the user data, I hope I really picked the right one, because I have 3. Let's see. No, it's not this one. Latest, yeah. This is the 29th, which is, I think it should be in the history. Okay, yeah. So here you can access all things. So for example, if you look at the DB password that you create when you instantiate the VM, that's going to be pushed to your EC2 VM. So you can even here I can put start a script. Like for example, this script is going to be pushed into your VM, and you can execute that. And it's the same thing you are doing in KVM in your local infrastructure. So that's the effort we wanted to do. All the same workflows, the same procedures that you develop locally can be put in the public cloud, right? I don't have time, but if you go to the console, the instances are monitored through tags. So, for example, when they have the one ID, they are assumed to be from OpenNebula. But if you delete that tag, it's going to be shown in the host as a wild VM. So you can, when it's get monitored, it's going to be shown here. So you can import any VM that has been spin up through the Amazon EC2 interface and import that in your local interface through OpenNebula, and then manage that VM in the same way. Okay. So this is basically how we manage hybrid cloud computing. If you have Microsoft Azure, it's going to be the same files or similar files, same procedures, specific attributes for Microsoft compared to EC2, but that's normal, and that's it. Thank you very much for your attention. Maybe we don't have time for questions.
Yeah, do you have any questions for the...
Yeah, I got one. On the version you're running here with the hybrid cloud, when you're under VMs over there, I saw you could VMC console VMs on it?
Yeah, but that's not really working. This is the...
So like that's not on.
This is the nightly build from master, so probably... No, obviously, you can VNC to your local VMs. Like this one, which is local, yeah.
Right,
but
you can't do it to the Amazon one.
that's right, you can.
Just wondering if you like got that in there like the auto.
Yeah, that magic is not ready here right now. Yeah.
Do you have a way to read user data where the request is coming from, rather than create a hierarchy of servers? Say, users logging in from South Africa, spin them up in the South Africa zone, rather than just straight hierarchy?
From the user, yeah, like the user picking up which. I don't think so. That's in the cloud interface. No, not really. But it really makes sense if you want to give that ability to users to decide if you want to go outside or.
Right.
Yeah.
Yeah, maybe you could create different templates.
Yeah, you can create different profiles. Like have a template for outsourcing, template for local. So you decide by the template and not by the You can define two different templates. It's not clean, but yeah, but there's a way. Yeah, it's a workaround for that. So here this is the VM I just showed you. So just to show you, it can be imported, and then you have a new VM. Either it's been created here or through Amazon EC2 console, and you can work with this VM and I don't know, probably terminate it. Okay. Yes?
Is there a way to have OpenNebula undefined storage locations so that I can use like EC2, like use Amazon or Azure or whatever, as compute nodes, but actually points to storage locations through OpenNebula?
So the same thing, but for storage?
Yeah, so basically I can deploy hybrid locations, that's fine.
Okay.
But I want, when I deploy it, I want through OpenNebula to have my own hybridized locations so that I can do compute nodes as a true hybrid cloud.
Mm-hmm.
So I launch my own VMs, which access some of the shards. I launch Amazon instances, which access other parts of my shards. And then it's a true hybrid. Is that capability?
Right now, but I'm not really sure if it's a good idea. I mean, our approach is more stateless, because if you want to really use your own images in Amazon EC2, you have to upload the images, right? At some point. So what happens when you have a security patch or you want to upgrade your operating system? You have to replicate all those changes in all of your locations. So I think it would be, or it's more convenient to have your Ansible or whatever configuration script. So you replicate the storage, or you put the storage in the cloud in terms of the VM image in the same in a well-known state, right? So you have, like, for example, a base CentOS image and a vanilla one, and that's your basic building block. Upon that, you install, configure, move for data to the image, but it's not really stored in the hybrid. So you don't have to upload content to the public clouds. I'm not sure if I'm answering your question, but
You're talking about images, I'm talking about also other storage.
like.
So like if I have other data that I want to access, will I access to my VM?
No, that should be application dependent, and it's not handled through here. Okay. Okay. So any other question? We can talk later.
Okay, thank you, Ruben.